Alright, so welcome to the coding session of anomaly detection. And I promised we will take a new data set that is more tuned to this type of problem. And that's a credit card fraud transaction data. It's data from September 13th and it was taken in Europe, so based on European customers. And the particular thing about this data set is where you typically have a very small amount or percentage of the positive class. You see there's almost 300,000 transactions, there will be 28 features, and there's less than 500 fraud cases or less than 500 class 1. So this would be class 0, and this is class 1. And that's exactly what we wanted, because our theory said that in this case you'll get better results with anomaly detection versus traditional classification, mainly because there's not enough training samples to train on. So it's something that we will try to see in the coding session. We will basically look at the three classifiers that we saw, which is local outlier factor. We will do one class support vector machine and isolation forest or isolated forest. And then we're going to compare this performance with traditional classifiers that we've seen, and one will be random forests, and one will be gradient boosting machine, where we will go with XGBoost. Why these two? Well, they have given us the best score up to this point. So let's see what they can do on this type of setting. Now there's a few options in terms of libraries on anomaly detection. One is sklearn. I had a lot of issues with that. There's a lot of code with respect to anomaly detection and sklearn, but the results that code gives is very puzzling. I think there's a lot of mistakes online using sklearn for this type of problem. So I found another library which is called PYOD. And it's easier to work with. In fact, we're gonna do 3-in-1. We will actually run all the classifiers together on the data. We will, I know it is unsupervised learning, but we will do a train test split so we can apply the algorithm on unseen data. And the split will be about 20%. This is the number we will use. All right, let's get to coding now.